student number 168 to 37, and in this video I'll demonstrate my contributions to the lab assignment, particularly data engineering question 1 and data analytics question 1, which I tackled. First and foremost, I'm going to show you my branch on GitHub. So here's my branch with the commits that I've made through the assignment. There's the transformer modification. There's also the analytics query and the submission document. Okay, so the first question I did was the data engineering question, where I was supposed to modify the database tables to add an item category. So in order to do this, I modified the transformer.py file. I added a new component or a new field, sorry, the item category, which classifies each item into either meat-based, grain-based, or vegetable-based. And to demonstrate the commands that I ran, after modifying the transformer file, I restarted I rebuilt the transformer container so that the new logic takes effect. And when I navigate to my ClickHouse, under my orders table, you can see that the item category was successfully added, where each meal is classified as either grain-based, meat-based, or vegetable-based. So that was how I tackled question 1 of the lab. The second question that I tackled was the data analytics question 1, where I was supposed to write a query that computes the average latency gap between received data and processed data for each item. So I'll navigate back to my Python. I put all the commands, the git bash commands and outputs in a single file because I noticed that every time I shut down PyCharm, they kept disappearing. So after I did all of them, I put them in a single file. And here is the command. So from the output, you'll realize that egusi soup's latency is 7.23 seconds, followed by jollof rice at 2.4, arranged in a descending order from the highest to the lowest. So you'll realize that egusi soup has the highest average, significantly highest average latency at 7.23 seconds. And the possible reason or explanation for this is that it's probably because it has very few orders. And because of that, a couple of them may have been processed during the pipeline's slow startup period, which pulled the average way up. So those are the two questions that I tackled: data engineering question 1 and data analytics question 1. All my work, the modified transformer, updated ClickHouse, the SQL queries, the written answers, and the command line evidence have all been pushed to my branch on GitHub and can be viewed by the lecturer. So yeah, that has been me, Austine Namayi, 168 to 37. Thank you.
My name is Emma Karanja, admission number 15739, and I shall be taking you through the question I was able to handle, or the question that I was handling. And the question that I was handling initially was question number 2, the write an analytic query in data engineering. So before all that, I was able to create a branch, Emma Karanja, whereby I created whereby I had to create a file in PyCharm where I'll where I was to now paste my my query, like the analytical query that I used and the answer that I got from the query. So before after that, after making the branch, I was able to open Docker. I I I I made sure my containers were running properly, and then that's when now I went to PyCharm and now did the the coding part of it. So I was able to now direct it to data engineering, and I made sure it was on the right path. And then later on, I was able to open ClickHouse by using Docker ClickHouse client and then ClickHouse password, which is lab password. And then after ClickHouse opened and I was sure that it was running, I wanted to check the number of tables that were in the order table, not the number, yeah, the number of tables. Yeah. So afterwards, I got a total count of 3,770, and I was sure at least my ClickHouse was running well. So later on, I now put the analytical query, which is sum and from orders, group of items, group by item, order by total quantity, whereby group by item, I was able to group this orders in terms of items only, and the order itself now order by total quantity, and the total quantity was to be displayed from highest to the lowest, and then I was to only get one response or one item that had the highest total quantity according to the question. So my query gave me a response, and nyama choma was the item that had the highest total quantity order. Then yeah, so later on, as early as I mentioned, I created a file whereby put I was able to put my work and to display my query and the answer and the explanation, and I was able to push it into GitHub. Yeah, thank you.
My name is Daisy Gachugi Gitonga, admission number 169975. I belong to group C6 and I'm supposed to do question 5 under data engineering about stopping a Kafka broker. First, I created my branch and I named it Feature Daisy Practice. And since the question I'm doing is under part 3 of data engineering, I added a new file whereby I modified the instructions and added the instruction for the demonstrating fault tolerance, which is stopping the Kafka broker, one of the Kafka brokers, and which is Kafka 3. I navigated to PyCharm, and after running the commands, especially the one for building the images and starting the services, uh, the containers have started successfully and they are running. And to demonstrate, even in the Docker desktop, everything is running, everything is okay. So to demonstrate the fault tolerance, I'll run the command of docker stop Kafka 3. which will demonstrate that the Kafka broker has been stopped. And when you check the logs, you'll find that even though the Kafka 3 broker has stopped, the rest of the containers are still operating. That is the producer, the consumer, and the transformer. Yeah, as you can also see in the Docker desktop, that the Kafka 3 has stopped running. Kafka 3 broker, as you can see, yeah, it has stopped running. Yes, then we can run the Docker start. This command um, is to make sure that the Kafka 3 broker rejoins the cluster, and when you check through the logs, you'll find that the Kafka 3 broker has rejoined the cluster successfully. And even when you view in the Docker desktop, it will be running. Yes, thank you. That is my demonstration of fault tolerance.
Hi, I'm Kimberly Ondari, admission 151, 112 from Group C, specifically C6. And I was working on question 3 under data engineering, which was about pipeline latency. It was about measuring the pipeline latency, so about the average delay between an order being inserted into PostgreSQL and arriving at ClickHouse, and also answering the question, what does this tell us about the pipeline? So first, I began by creating my individual branch, which is right here. So after I created my individual branch, I headed over to PyCharm. And since I was doing a question under data engineering, I created a file known as pipeline latency, which was for my question. Here it is. And here I filled in the details of whatever I'm going to get before I run the tests. So running for the containers, I was using PowerShell. So this is demonstrated. So yeah, where I was prompting the commands for the containers on Docker. When I head over to Docker, for this question, the main interest is the ClickHouse, and we can see the live ecosystem driving this data. We have Apache Kafka running as the event broker and ClickHouse as the analytical database. So after running the commands on PowerShell, I was able to get 1.5 seconds. Able to get 1.5 seconds 1.5 seconds as the pipeline latency, and this shows that this has a very low latency. So from here, Docker, we can see that Kafka passes like all the events instantly, and then ClickHouse indexes them immediately and causing real-time streaming capabilities. So to answer the question, what is the average delay between an order being inserted into PostgreSQL and arriving at ClickHouse? I got that as 1.5 seconds. So what this tells us about the pipeline is that it has a low latency, which means it's highly efficient because it's like water flowing through a pipe, meaning the data is being processed as fast as it's being produced.
Maureen Waweru, 168663 And I was tackling question 4 under data engineering and question 2 under data analytics. So for question 4, sorry, I was to run this command and inspect the replication slot created by Debezium. But to start, I ensured that my Postgres container was running in Docker. Then I came and executed the command. So the slot name after the command executed, this is the output that I got. So the slot name is debezium underscore slot. And the thing that stood out to me was the active F, which after researching on it, it showed that active F means that the slot became inactive since debezium stopped. So this slot will be kept open by Postgres because Postgres assumes that debezium will eventually turn back and will have to continue from where it left off. And on top of this, the data in the wall, the write-ahead log from the slots will be retained as well. And since the unused slot remains open, it will have a great effect since Postgres does not delete the files generated and even after Debezium stops. So this poses a big risk since the database will continue piling up with the write-ahead log files, and if the disk space is left unmanaged, the storage drive will reach maximum capacity, and eventually the database might crash. Yes, so that was question 4. Then lastly, for question 2, I was to extrapolate this equation where if the 500,000 query takes X seconds on Postgres, approximately how long would a 50 million query take? Then the other question was, is Postgres a viable tool for that scale of analytics? So for this question, I calculated it. So if the 500,000 row query takes X seconds, how much would the 50 million query take? Then I divided the 50 million query by 500,000 and it gave me 100. So the 50 million query is 100 times larger than the 500,000 row query. Then to get time t, now the time taken by the 50 million query, I did the 100 by x to get 100x units time. But then to get a more practical idea, I give x a value. So I give x is equals to 5 seconds. So this was assuming linear scaling. So after that, I did 100 by 5 to get how much time the 50 million query take. So this gave me 500 seconds. So the 50 million query would take 50 million row query would take 500 seconds, and the 500,000 row query would take 5 seconds. Then the question on if Postgres is a viable tool, my answer is no. Postgres is not a viable tool for that scale of analytics because Postgres scans tables row by row, as illustrated here, which causes massive memory bottlenecks and heavy input-output operations when aggregating so many rows. However, tools like ClickHouse, which are columnar stores, are better for handling that amount of processing compared to traditional databases. Since these databases only read the columns requested, making them way faster than the traditional databases. Yes, so those are the two questions I was tackling. I will proceed to show my GitHub. So this is my GitHub branch, Maureen / Waweru. Yes, and I made my changes in the lab submission instructions file. So this is where I answered my question. Yes, thank you for your time and thank you for listening to our presentation.